Good day everyone. Welcome back. Today, I will be presenting a civil project, modeling a modular bus stop shelter family, and developing a sample bus shelter based on this family. This elegant design is widely used across Singapore's public transport system in Singapore for a decade and remains in use today. The objective is to create a modular bus shelter family with parametric controls for flexibility. The focus is on modeling techniques in Revit. I will cover key steps required to build the family efficiently, not every small detail. Going to start with step-by-step create the model. This family requires, placing one single adaptive point initiates the modular skeleton. Reference to this adaptive point number 1, create more reference point number 2, number 3, number 4, number 5, etc., by appropriate working planes and referencing each other, indicated in this image with step-by-step modeling numbering sequences, then to form the modular skeleton. Let's begin by creating a new family using the metric generic model adaptive family template. Place an adaptive point number 1 anywhere on the face, it doesn't need to be at the exact intersection. Based on this point number 1, create additional reference points number 2 on appropriate working planes. Place a point on a horizontal working plane and set an offset of 2200 mm for the post height. Associate with instance parameter for varying it to control dimensions individually with flexibility and project. Let's define it h for height, and 2200 mm offset for now. Add another point on horizontal plane with an offset of 100 mm define as gap, should be a type parameter, actually should be small gap for 3 mm to 5 mm only, I will change it later on. Next, add again a new point on horizontal plane place for rafter base at 50 mm offset, and type parameter set. And, an additional point at fixed 350 mm offset for the top part of the post. Then connect these points with line and make reference lines. Next, create a point for the roof frame. To do that, referencing with a parameter h1, ensure place on horizontal plane. Set at 550 mm offset, this point should be above. Reference to this point, using vertical working plane, place point to define the roof back offset, drag some distance back. Different movement direction, and give negative 400 mm, this should control with parameter. Define parameter as covered back. Referencing this point again, next point on vertical working plane, drag it to front. And create parameter with covered, L, and set for type. Place one more vertical point for forming slope. New parameter with h2. Let's create new parameter to introduce a slope with angle parameter as set at 4 degrees. It's introduced along with a formula to calculate the vertical offset h2 for the roof slope, allowing dynamic adjustment. As I've known that angle, A, and adjacent side. Using simple trigonometry formula to apply. Covered length by tangent angle A. This should give me some computed offset value to raise up for this point. The point, linked to parameter h2, connects with that point behind, make as reference line. Let's see from side elevation. Next, I will need 4 supporting rafters. The rafter is created as a separate nested family with adaptive points. I will define full and half span to position the rafters accurately and connect them with reference lines to form rafter base to the structural grid. Place point it back on vertical plane. Drag the point as direction to the right, create parameter, span half, and type parameter to set. Add additional point on current point to left opposite side as full span. Requiring span point movement direction to correct. Should control by another span negative parameter with formula. Define and set typical value 3000 mm for new span parameter. And another parameter span half will be simply half of span. Place each point for half span and full span on vertical working planes, controlled by span half as new parameter, and another point to place on vertical plane, due to point direction, should control by span negative length parameters. Repeat reference 2 more points for front as well. Then link to span half. Then link to and span negative parameters. Having 4 reference points to form a roof parameter. Let's connect each corner point by reference line to rafter base point, getting form the structural grid. Connect these to create the reference line for the roof parameter reference lines. Now, to create the rafter family, the rafter is created as a separate nested family with adaptive points by metric generic model adaptive family template. Create 2 adaptive points. Connect with reference line. And draw rectangular profiles on vertical reference plane for the rafters. Size 80 mm by 250 mm height for base profile. And 80 mm by 50 mm for another end. Create solid geometry using 2 profiles. Place to both ends by normalized curved parameters range 0 and 1. Or, drag them to each end. And then, assign a structural material parameter ST for consistency and easy control. Load is nested family into the main family. Place component, host point on rafter base first, then next location at this point in front of span. Look like orientation something went wrong after placed. To fix this issue later on, let's continue to install the rest 3 rafters. Back to family 2. Ensuring the always vertical option is checked. Then load it to project back, overwrite the existing version. Now, it's work properly. Test parameter changes, such as adjusting the covered length obed covered back, to verify flexibility. Loaded family 2 to be renamed in project browser under families category, this family to rafter, also rename the family type. Next, create the circular post family. The post component is created with placing a point and using circular profiles with controlled diameter parameter on horizontal plane along reference line. Define the parameter DIS set to 180 mm. Here. First, create upper part post, to host family 2. With circle profile with point. Link to DIA parameter. And create solid form. Continuing for main post. Let's copy profile. Pick for new host somewhere above. And create by both profiles and generate solid forms with associated material parameters, name ST. Stretching to both ends, with normalized curve parameter values for each point, entering 1 for top and 0 for bottom position. Update the rafter family. Family to include a circular void cut as post radius of 90 mm for proper connection to the post. Load the updated families back and overwrite the existing version. Then, adjust the gap parameter to 10 mm. Also to adjust the modular span. The typical span is 3000 mm. But due to roof frame 120 mm width, shortening the span slightly by reducing 120 mm in total. Adjust the span to 2880 mm and covered back to 350 mm. Ensure to check by dimension. Reference to roof shape. Add a point to extend the middle reference line with fixed negative 350 mm for the curved roof extension behind. For the curved roof, create each point on mid position for two sides and middle reference line. Then, additional each point for offsets are carefully placed. Get 100 mm offset for 3 of them. Create reference lines for 2 sides. Add point for back of center extension with offset lowering. And connect reference line. This dropped offset to match the roof's curved form through trial and error. Adjusting this offset lowering by -35, -85, -65, -75 mm will be perfect fit the curvature. Some adjustment to make for back curvature shape. Next, to create the roof perimeter frame. Draw profiles 120 mm by 50 mm at points on the vertical reference plane selected and create form along the perimeter curves reference line. After that, structural material parameter is applied for consistency. Let's create 3 additional components. First component is lamp family. It's on top of the circular post using metric generic face base template. Create a circular base with a gap by extrusion. And revolve for a fixture above, to match with post diameter. Assign the structural material parameter for base and glass for top. Load to main family and install. Remember, loaded family to name and project, family 3 to lamp. Second component is end cap family to create at rafter ends as half ball shapes. Using metric generic face base template as well. Create form by revolve. Assign material parameter. Load and install underneath at host, roof perimeter frame corners. Third component will be end shade family to create for both ends at roof frame, to match and flex with side curvature, probably, to use metric generic adaptive template. Based on 3 adaptive points and reference line. Create a taper up and a fillet profile end. Duplicate for next host, place to both ends by normalized curved parameters range 0 and 1, or, drag them to each end, and create a shade form by both profiles. Load family to main family as nested, and install on roof frame side. Do need family modification, back to family and check option for always vertical, load and overwrite the existing is required. Install for another side. Rename for end shade. This point, create and controlled by visibility parameters on and off flexibility. Create and test visibility parameters for shade left, shade right, or no shade options in different shelter configurations. All good. Save the family as modular bus stop shelter. Alright. Time for creating new architectural project. In the project environment, I've created a floor to host the family and road layout. Load the completed modular bus stop shelter family into a project. The modular shelters are placed multiple instances along the road edge. Place one here. Ensuring proper spacing and alignment with 600 mm behind the road edge. Next one here. And next 2 more components. Leave first component as single standing. From second component, use array command or shortcut AR to duplicate for array. Move option to second, default number of 2, and move distance 3000 mm for typical span width. Repeat for all. Array groups apply with number 2, number 3, number 4, let's place new group as 7. And space the shelters with parametric control over height to 2700 mm, yes. It's raised. Covered length to 3000 mm. Align front edges. Next group, 2500 mm. 2700 mm. 2900 mm, etc., to varies the coverage. And last group with same coverage 3000 mm length. Give different height parameters for varying height for last group. Control with visibility parameters. Within each shelter group, end shade components visibility to control. Most left component visible for left end shade, unchecked for right, and for the most right component to be opposite option apply. Both end shade invisible for all internal components. To enhance visualization, color coding is applied to different shelter groups using material browser colors. I've created different material colors for white, black, gray, yellow, even pink, green, and blue as well. Let's look at all components to other side. Apply different material colors them for visualization. White first. Next to with black. Next, go for yellow and green. How about pink material for ladies? And a sign with red, blue and as well. White for the last component. Standard material color code gray for the rest at opposite side. Shadow on for reality. Add the roof components. The roof to be coincided with roof frame curvature and slope. Two sides with curves, straight at front, a curve down at back. To create that, I will use metric generic model adaptive family template. Place 3 points left to right. Next 3 for center and last 3 for opposite side, all to make adaptive points with number sequencing. Connect reference line to adaptive points 3 each. Select reference lines and create form. The roof I have it. Test for flexibility. Each 3 points to host on roof reference points. Create material parameter, name to roof panel. This family 5, load nested into modular bus shelter family. Install at host first on frame edge, second host on frame mid then the other edge. Next 3 points on center reference line, on point below, on middle point and point on frame. Last 3 points on next to roof frame. All good. Roof panel perfectly installed and follow the roof frame curvature. Rename new family 5 to roof panel. Now, family become roof panel in main family. Modular bus shelter family creation has completed. Load in to project for loaded modular family upgraded, overwrite the existing version. Yes, updated with roofs to all components in project. View from side elevation, set back 600 mm from road edge, all components formed varies shapes and heights parametrically, and, this side with standard color code of gray. Here's material full colors set with modular components on other side of road. To add more components, due to time consuming, I will skip all simple family creations. Let's add a bus information panels, load and place in project. Also to add typical bus ID polls. And in addition, a flexible seat families to include and place where necessary. With or without armrests options. It was controlled by visibility parameters. Entourage are added for realism. You can see the travelers are waiting for buses. Finally, to install the bus shelter name on the end shade by face-based family. But this bus shelter location and road name won't be able to find in Google Map and Street Directory, haha. This modular bus shelter family is now fully parametric, flexible, and ready for use in various project configurations. All good. Let me save this project. Name with parametric modular bus stop shelter type in Singapore. Save the file. These are some images from this project. Thank you for your attention. I look forward to our next session. Thank you and goodbye.